Thank you for the nice introduction and setting the stage for today's session. Before I deep dive into today's topic of warehouse digital twin, I would quickly like to give you a brief introduction about Volvo Group and the function I belong to within Volvo Group. Volvo Group consists of a number of different business areas, example Volvo Trucks, Volvo Buses, Volvo Construction Equipment, Volvo Penta, Renault Trucks, Mack Trucks, and some more. Then we have something called as truck divisions. That is Group Trucks operations, supporting the operational aspect for Volvo Group, Group Trucks purchasing, and Group Trucks technology. The function that I belong to is called as Service Market Logistics. Within the truck division, Group Trucks operations. And as the name says, we are responsible for the service market or aftermarket or spare part needs and distribution for different business areas within Volvo Group. As you can see on the picture, we are present everywhere in the world, with more than 700,000 square meters of space, more than 700,000 parts stored, while handling more than 27 million order lines per year and delivering value worth more than 25 billion Swedish kronor per year. With that introduction, let's deep dive into today's topic, that is warehouse digital twin. When you look up the definition of a digital twin, you will find different definition. But what you see on the screen is a simple definition that I relate to most. That is, digital twins are virtual, near real-time digital representations of physical objects or processes, bridging the physical and digital worlds. Meaning, a digital twin is created when you can connect a physical object or process with the connected near real-time data. And that is when the magic happens. So how does it work in a distribution center or a warehousing environment? It is quite straightforward actually. There are two main components. That is, firstly, we have lots and lots of data in our warehouse management system. And secondly, we have the physical facility with the actual parts and locations. When we look at either of these two things standalone, we definitely can understand and know a lot about operations on a high level. However, when we merge both these things with virtual visualization of the facility connected with the relevant data, we can get a lot more actionable insights. For example, we can visually see where are the locations with most transactions and are they the best locations from an efficiency perspective. How does the fill rate looks like for different zones and aisles? Do we have the right weight distribution in the right locations from a safety perspective? Or which day of the week and hour of the day do we have the highest volumes? Then the next question that I always get is, how is it better or different than all the advanced analytics or analysis that a lot of you on the call do about the fill rates, operational analysis, and so on? The answer to that is visualizations. That is the USP of the solution. It is all about simplifying things for us and our people. And what can be better than if we can make analysis files look like how it looks in reality in the distribution centers. You see the pictures on the slide here. It explains itself. Compare the reality first to how a typical report looks, and then compare it to the digital twin pictures on the right-hand side. Which one do you think will be easier for human brain to comprehend? You will see more details later in the presentation and the tool demo. Also, please do not forget to ask questions using the chat functionality in the webinar. So based on this, why and what of digital twin, we decided to initiate this activity and found a great partner in Meridion, who have actually developed the solution for us. And you will hear more about the actual tool with a demonstration later from Johan in the session. This picture is just to give you an idea of how does the virtual world of digital twin compares with the real world. You have the view of a zone on the left and an aisle on the right. On the zone representation, you see some red dots on both sides. That is a clickable button that can be clicked to decide which particular aisle and which side of the aisle you would like to stand and view the details of the aisle. This particular slide shows different types of analysis and visualization sheets available in the digital twin desktop version of the application. If we start from the top left, the first picture that you see shows a two-dimensional interactive picture of the warehouse layout with zone numbers, where you can basically click a zone number to get a detailed zone view and visualize different sets of information. Example, number of transactions, weight information. Also, how you should read the color is that the darker the color, higher is the value. Meaning in the zone view picture that you see, the dark blue color signifies the higher filling degree. The picture on the top right shows a heat map to analyze when do we have the most number of transactions in terms of the day of the week and the hour of the day. And of course, you can filter in the information based on if it is either inbound or outbound. This kind of analysis is very helpful for operational resource planning. The bottom half visualization shows an example where you can zoom into a particular aisle within a zone to look at the transactional frequency for each location. And the bottom right-hand side picture is where it gets even more interesting. If you look closely at the highlighted section, you can see that there is extremely dark color on bottommost location. Whereas on level 5, there are no transactions registered over the last year or so. And bear in mind that this is an area within the warehouse where you actually pick by hand. So what does it imply? It means that we are forcing our people to bend down to pick parts, and a lot of them, while the most convenient locations to pick by hand are having no transactions. And when you visualize it like this, it makes it very, very simple for operational colleagues to make daily improvements. So, what are the different use cases that are being covered as part of the digital twin? The most important thing for us is our people working in the distribution centers. And this application helps us to improve safety and ergonomics in our environment with parts located at correct height and in the right zone. It is allowing us to effectively manage warehouse space by providing real-time visibility of empty locations. One of our operational colleagues in a DC once mentioned to me that they are able to create workflow tasks, relocation tasks based on the irregularities in the DC while sitting in his office, which has been very, very difficult even with the Gamba rounds in the past. On top of that, it has been helping to improve the PDQ performance, also the instant reporting of the fast and slow movers. Normally we say the bad data leads to bad analysis. However, in this case, it is not entirely true. I will explain how. When the digital twin is created, it uses the data from system to map and create the layout. And when the data is not right in the system, meaning, for example, if there are locations in the system that does not exist in reality, what we see is aisles being created that are going beyond the roof or locations going outside the boundaries of the warehouse, which actually triggers cleaning of data in the system. So the tool has been actually helping in improving the data quality. Another big use case is the ease of communicating improvement tasks to teams during the daily communication meetings, and also the ease of understanding for the team. And for sure, it provides a clear understanding of the DC's current state. This is a slide explaining the soft aspects for implementations. How have we done it so far? What is the difference compared to traditional developments, and what have we learned? The first step in the process is that the respective site has to raise hand and request for implementation based on the high-level business case. Traditionally, we have had push-based implementations with focus on speed and standardization, which definitely has its own advantages. However, in this case, it has purely been pull-based, where the site takes the full ownership, identify the need, identify the value, and take full accountability and drive of the implementation. All implementations are driven on individual level. However, there are end-to-end roles clarity and ownership. Then once the actual implementation project is initiated, it is a one team in real sense, which is global and regional teams, IT teams, and the partner in Meridion. Since the setup is very streamlined and everyone is so aligned, it just takes 12 weeks to implement from beginning to end, including the fine-tuning and the review of the final version of the application. And once the final implementation is done and running for a few weeks, the sites put together the final business value and commits to the improvements, including both the soft parameters, but also the real and the tangible parameters. For example, the number of order lines handled per hour and so on. This is actually the final slide that I would like to share with you, but also with a message. We had our very first implementation in 2019. And then we spent a lot of time in communication and sharing with very clear mindset that we will not push it. And the site needs to ask for it and take ownership of the improvement. Agreed that maybe we lost out on a couple of years of potential improvements, but it was extremely important for us that our people feel the value, people feel the need, and take the ownership of the solution. So when it finally moved, we have had 6 implementations in single year last year, taking the total to 7 implementations. And right now we have 3 more implementations ongoing as we speak, and many more in the pipeline. It has also been included in the standard application portfolio for the organization, and going forward as well, there is no big bang project plan. But still, we can say we have a global vision for the solution. And with that, I would like to thank you for listening in. And now I would like to hand it over to Johan to give you all the actual demonstration of the solution.
So thank you, Vipin, for that introduction. And now we're going to the demos part of the session. But first, a short slide on the Meridion company. So Meridion is a consultancy company that focuses on supply chain management, and we're working with the tools from Qlik and info regarding the ERP part. And the digital twin for Volvo is one of the packages that we have brought together in order to facilitate and increase the performance from our clients. But let's get straight down to the demo. And I will take you to the visualize part where we have a copy of the digital twin from Volvo. And we will be transferring ourselves to the Eskilstuna warehouse, which we can demo. Of course, the Qlik environment at Volvo is locally, so they have an online update of the data. So what we're looking at here is a set of use cases that Vipin described earlier, and we will start in the fill rate part. Looks like this, and the first thing that we'll look on is the fill rate on the areas itself. So this is the actual facility drawing of the warehouse, where we actually put in small areas of the zones within the warehouse. The darker the color, again, the more fill rate, or the higher the fill rate. So if we look into one of these zones, go into zone 20, and we see the top perspective. And as you see here, you will have less fill rate, for example, here. And we also see that there's something missing here. So we look into this one by clicking the yellow dot, the red dot. and it opens up this aisle perspective. What we directly can see here is that we have something missing here. It's probably a ventilation shaft or something. We can also see that the fill rate, which is the yellow, means that it's not, it's an empty location. So we have the filling has been going on like this and not filling up here, which is also displayed in the over top view perspective. So in this case, we have less fill rate at this end of the warehouse and higher here. If we then look into the next aisle, we would expect the same situation. So we click this one, but there we have a less fill rate on the first side here. But then in general, we have the opposite direction of fill rates. So it goes over here and getting less and less fill rate. So what is the reason for this? And that's actually a way for us to see the algorithms working of the system directed put away. We can also say that this is around 6,500 locations that we see, and each of these small boxes are displayed here in a typical picture. And one of the Meridion parts is that we have developed a tool that is actually generating these pictures, which is a big part of the digital twin. Because when we take a look at the site, we are looking at it from a system perspective, meaning that we draw the pictures based on the system files that will generate the picture. And then we go to the reality and check if it's real. Because if it's not, then it means that the system has information that is not correct. A good example of that is here, where we see that we have totally no fill rate up here, but it's still drawing the locations. The reason is that those were rebuilt and actually taken away from the reality, but not from the system. So of course, one action was to reduce this so that the system will not propose to go here. When we're looking at this one, or we can go back here, we can switch from the fill rate perspective. We can switch to the transaction frequency perspective. It's the same functionality again, with just some other metadata coming up. What we see here is that we have some areas or locations with a high runner, dark color. So we can select this one or this one, for example. Take that one. And then we see that we have 129 picks on that location. We can take that and go to the pick savings tab or the sheet. And we had discussion with these ones that the timing of actually going up to this level took 21 seconds and 25 to go down again, make the pick, put it back up and down, and go to the next area of picking. So if we amount that to 40 times 2, that's about 80. And the average cost for the forklift and the user, $35 an hour, we can show the savings. And we could probably save 1.2 hours, $42. So going on the frequency line, we see that this is an AA class item, meaning the number of picks are in high frequency. So we select all AA items, and here we see the good power of Qlik. We deselect, and we take, let's say, the height greater than 15. Maybe then we don't save as much in time, so we decrease it a bit. And then we take away the location, and you will see all the ones. And now we're coming up to a little bit more hours of savings, if we can move it around. And then we take away the complete aisle, and we get some more just for this zone. And we also get a good example of where we're actually storing the things. So there are some quite potential just operational savings if we can move it around. But then the question is, do we have a better location stored, or is all locations moved continuously? So let's move back to the fill rate and saturation part. And let's look into the same aisle that we had earlier. And we'll see, let's check the move year last time for this. So we deselect the heights. And we have the same location zone, and we check the move year for those, this aisle. And the data for this was actually extracted in November 2017. So if we check the ones that has not been moved since 2016, we get this perspective, which we see is both the bigger locations and the smaller. So there should be a good possibility to relocalize the items so we get a more efficient picking pattern. Another way to show this example is that we go into another aisle and we check what is in area 30, where we have a different pattern. So again, the system is driving and bringing the pictures, and then we align it according to reality. We can drop into the last line here by clicking the red dot. We get this perspective, and this information is of course displayed as well in a table. So let's check for these and see which ones that has been or will be moved in 2020. Again, it's a bit tricky because I said that the data was read earlier than 2020. But what is the data that we see here then? Can you see the picture? I'm quite sure you can't, but if I do this, you probably can. So this is just a quick way to show the power of visualization and what we can actually see in the applications. So I hope you enjoyed that. And currently, as we said, we're on 7 sites, and the sites are quite big. Details are not disclosed fully here, but we're on about 500,000 locations and 26 different use cases as we have for now. I also wanted to take the opportunity to show you a little bit on what we think is the future, and to use additional applications powered by Qlik, and in this case Unity, to build a 3D application of it. We divided, and now we have focused on the 2D version, but there is also 3D keyboard version and the virtual reality version. I will run the demo now on the 3D version on my old 3-year-old Lenovo laptop. So it's actually not requiring a gaming laptop, which of course the 3D virtual reality does. So let me take you into this environment. And again, this is what we see, a warehouse with the VR pictures that's incorporated from CAD or so. And we can initiate Qlik here just by adding, as we saw before, the on-hand balances like this. The same idea. We can also switch over to transactions. We can directly identify if we have high runners coming in different locations. I know that I have one over here, for example. So looking into the aisle, we can check this one. We get 86 transactions. So it also gives you a little bit of additional feeling of being actually in the warehouse. Same data model as in the 2D version. but a little bit different interface. We can also put the ABC classing like this, or search by free text. So this is actually what we see is the interface to the Qlik user, or the Qlik engine. But that's all I wanted to show you around that. Of course, it's different ways that we're using these different tools, but it's the same data model, which is very important. So let's get to the next topic, which is project planning and implementation of a warehouse digital twin. We have divided it into these main activities, where we're starting with the data extraction. It might seem a bit tricky to do that, but it's quite simple data that we get, and we need it to do the pre-mapping. The pre-mapping is actually the first version of the digital twin, so that we can directly go into the next step, which is the validation, where we actually use the digital twin to verify the system data versus reality. And in parallel to that, we are using the existing use cases and also develop some potentially new ones that comes up with the ideas that we see on the digital twin. Today we're at 27 use cases at Volvo, and it's developing over time. The next phase is to do a remapping, which is basically bringing the digital twin more close to the reality. And the final step is how to implement it into the operational processes and also the IT deployment with the reloading functions, etc. In order to do this, we have divided into more detailed plan, of course, and we are normally running it and planning it for 8 to 9 weeks with a usage function after that and a feedback session, so that we are sure that it's actually used at the site. To be that quick, we're using the different checklists that we're sending out to the project sites. And I'm just going to show you 2 examples where what we're sending out, and we're requiring back information about the layouts and the rough drawings and an overview of the aisles, etc., and some photos to get a good understanding. We also want an overview perspective so we can put the zones and the racks to the right compartment, and because we are basing the digital twin on the system data later on. There's also one function that's very important, and it's that prerequisites, of course, to be clear for the site. Otherwise, it will take some good time. And the project is then run on the Meridion Qlik portal, which we call Visualize, or internal Qlik server, which is at the client, or we do it on Qlik. Of course, we need access to personnel on site, etc., and photo permits and so on. An important part is also that the location naming should follow some kind of structure in order for our generator for the pictures to work. We have also defined a very quick focus project that we do with 2 to 3 persons on site for 2 weeks with the development and including the final presentation. So it's actually a quite quick process to get a good understanding of what we could use the digital twin for. That was all from the project planning perspective. Thank you so much, and over to Martin for the generic business case.